Long before synthetic fertilizers arrived and agriculture became mechanized, our grandfathers had an unusual secret. They buried certain materials beneath apple trees. It wasn't manure, it wasn't compost, and it certainly wasn't the chemical fertilizers that dominate modern orchards. Yet those trees thrived. They lived longer, resisted drought and disease better, and bore fruit consistently over decades, sometimes for generations. This was not a ritual, nor was it superstition. It was a carefully observed practice, refined over centuries through experience and quiet observation. Children watched their elders dig the holes and place the materials carefully, learning the secret without needing explanations. "Put it down there, the tree will know," they would be told, and indeed, the tree did. The logic was simple yet profound. Apple trees are perennial organisms with long-term nutrient needs. Surface feeding encourages rapid leaf growth, weak branches, and fruit that is soft and short-lived. Our grandfathers understood that for longevity and deep resilience, the tree needed slow, consistent nutrition delivered where it could not be washed away by rain or exhausted within months. What they buried was not designed to be consumed immediately. It was meant to last, to feed slowly, and to nurture the tree through decades of growth. The choice of materials was deliberate, based on density, mineral content, and slow decomposition rates. These materials created a reservoir of nutrition protected from the elements, waiting underground for the roots to discover it naturally. This practice illustrates a key principle. Gardening is not about instant results, but about anticipating the future. Our grandfathers built a foundation that trees could rely upon long after the planter was gone, a system designed to work with natural processes rather than against them. And in doing so, they achieved something modern horticulture often overlooks: self-sustaining, resilient orchards. Beneath the apple trees, they buried materials that modern gardeners would rarely consider. Fish heads, whole small fish, animal bones, horns, hooves, wool scraps, and sometimes thick leather pieces were placed deep in the planting hole. At first glance, it might look like a waste disposal strategy, but it was far from random. Each material served a unique purpose. Fish remains were rich in phosphorus, calcium, iodine, selenium, and trace minerals essential for root development and fruit quality. Because fish decays slowly in cool, oxygen-limited soil, it released nutrients gradually over years instead of weeks, feeding the tree's root system and surrounding fungi in a controlled manner. Bones were even more effective over the long term. Their calcium phosphate content dissolves slowly, feeding woody tissue formation, enhancing structural integrity, and supporting healthy fruit development over decades. Horns and hooves function similarly, providing a dense mineral source resistant to rapid decomposition. Wool and hair had another function entirely. Decomposing extremely slowly, they released nitrogen in microdoses, avoiding the rapid vegetative growth that leads to weak branches and pest susceptibility. At the same time, their fibrous structure improved soil aeration and water retention, creating ideal microhabitats for beneficial microorganisms and worms. Leather scraps, while seemingly unusual, contributed dense organic carbon and protein. Buried deep, they maintained a steady supply of nutrients over years. All of these elements combined to create a mineral bank beneath the apple tree, a long-term investment in resilience, health, and productivity that modern fertilizers cannot replicate. Importantly, nothing was placed near the surface. All materials were positioned beneath the root flare, out of direct reach, ensuring the tree developed deep roots that could search for nutrients gradually, establishing strong fungal symbioses along the way. This is why trees planted this way thrived, far beyond the lifespan of conventionally fertilized trees. Why did this method work so well? And why is it superior to manure or chemical fertilizers? The answer lies in understanding apple tree biology and soil ecology. Manure releases nutrients rapidly, especially nitrogen, which stimulates immediate leaf growth. But fast growth creates soft, weak wood, leads to excessive pest attraction, and reduces fruit quality. The buried materials function differently. They fed fungi first, not the tree directly. Mycorrhizal fungi colonize the tree roots and explore the soil, retrieving nutrients from decomposing fish, bones, wool, and leather. These nutrients are released to the tree gradually, following natural demand rather than forcing the plant into a growth spurt. This regulated system minimizes stress, strengthens the root fungal network, and stabilizes nutrient delivery over decades. Calcium from bones strengthens cell walls, reducing fruit disorders like bitter pit. Phosphorus from fish and bones supports root elongation, flowering, and energy transfer within the plant. Trace minerals prevent deficiencies that could otherwise appear in older trees. Nitrogen from wool and hair is released so slowly that it maintains steady growth without pushing excessive leafy tissue. Beyond nutrition, these buried materials improve soil structure. Fibrous wool, hair, and leather maintain aeration and moisture retention, creating a stable environment for beneficial bacteria, fungi, and earthworms. Roots navigate this structure naturally, strengthening the tree while establishing microbial partnerships that improve disease resistance. In essence, the burial system is a self-sustaining ecosystem. The tree, fungi, and decomposing materials form a cycle that supports long-term health, unlike fast-acting fertilizers that disrupt microbial balance and force short-term results.
Trees planted using this deep burial technique behaved markedly differently from conventionally fed trees. Early growth was slower, often frustrating to impatient growers, but that slow growth laid the foundation for strength and longevity. Trunks thickened evenly, branches hardened, and roots delved deeper into mineral-rich soil. When fruiting began, it was consistent and balanced. Apples developed thicker skins, higher mineral density, and significantly improved storage life. In an era before refrigeration, this quality determined whether fruit could last through winter without spoilage. Calcium from bones reduced internal breakdown, phosphorus supported balanced flowering, and trace minerals enhanced immune response to pests and disease. Many apple trees still standing today owe their survival to this method. While modern orchards often collapse after 20 to 30 years due to rapid growth and shallow fertilization, these old trees endured decades of harsh winters, droughts, and pest cycles. Their soil was prepared once deeply and then left alone, allowing nature to take over. This approach also supported orchard resilience on a systemic level. Trees required less human intervention over time. The buried nutrients maintained the health of the microbial community, stabilized water retention, and encouraged deep root systems capable of withstanding climate fluctuations. This longevity was the key metric of success, not immediate yield.
This ancient practice is not folklore, it is applied biology. Modern gardeners can benefit greatly from understanding and implementing it. When planting an apple tree, dig a wide hole exceeding the anticipated root spread. Place dense, slow decomposing materials beneath the root flare: fish remains, large bones, horn meal, wool, or leather. Cover fully with soil. Plant normally. Avoid fast nitrogen fertilizers at the surface. Allow roots to grow downward naturally. Allow fungi to connect and extract nutrients. The tree will gradually consume the buried materials over decades, developing strong roots, resilient wood, and high-quality fruit. This method creates drought resistance, long-term nutrient stability, and reduced dependence on frequent fertilizer applications. Orchard health improves holistically. beneficial microorganisms flourish, pest resistance strengthens, and the tree's own natural systems regulate growth and fruiting. Garden Lore Vault exists to preserve these forgotten systems, practical wisdom that industrial agriculture dismissed. Our grandfathers did not bury waste, they buried time, resilience, and foresight. Trees remember what humans sometimes forget. By practicing this method today, gardeners reclaim centuries of lost knowledge and grow orchards that can last lifetimes.